Well, good afternoon, class. We're now starting chapter 2 in the book, and it revolves around, the first part revolves around something called kinematics. It's cars accelerating, traveling certain speeds, accelerating, but then also decelerating, and that's what we're dealing with right now. Now, the first thing is we have to be aware of, and it's on the board right here, is the term acceleration. Acceleration means your speed changes. You're in your car, you're going 30 miles an hour, you step on the gas and it speeds up to 50 miles per hour, and it takes a certain amount of time. The speed changes with time, and that's acceleration. Now that's A. A stands for acceleration. V sub 0 or V sub O, that's the initial velocity. Like if your car is at rest, it's not moving, your initial velocity or original velocity would be 0. If you're traveling at 30 miles per hour, then the original velocity would be 30 miles per hour. Now next to the symbol V sub O, original velocity, in parentheses it says m/s. That means meters per second. Meters per second. In acceleration, m/s squared, that's meters per second squared. So you have V sub O, that's the original speed. V, that's the speed at a certain amount of time, maybe after 10 seconds. T stands for time in seconds. And x minus x sub 0, x minus x sub 0 is the horizontal distance traveled. And that would be in terms of meters. M stands for meters. Now, if you remember in the laboratory experiment, where we did the metric system, we talked about meters. Now, in page 2-3 of the textbook, I have these equations. They're on that page, and these are the equations we use in this first section of the book about kinematics. One equation is V is equal to V sub 0 plus A times T. V is the final speed, V sub 0 is the original speed, A is the acceleration, and T is the time. The next equation says V squared, that's the final speed squared, equals the original speed squared, V sub 0 squared, plus 2 times acceleration, 2 times acceleration times distance, x minus x sub 0. The third equation says it's the distance. X minus x sub 0, that's the horizontal distance. You're traveling in a straight line down the street. That's equal to the original speed times the time, plus 1/2 the acceleration times the time squared. And finally, the last equation in this section is about the horizontal distance traveled. The horizontal distance traveled would be x minus x sub 0. That's equal to the final speed plus the original speed divided by 2 times the t. And all this refers to uniformly accelerated motion. It's constant acceleration. So the acceleration is not changing as you're traveling. Now what I'm going to do now is I'm going to go to the book and we're going to do some of your homework problems. So again, the lesson plan is going to have all the problems that you have to do. Also, I have example problems in here, like on page 2-4, I have example problems 2-3 and 2-4, and they're worked out very carefully for you. All right? Now I'm going to go back here to page 2-8, and I'm going to pick a problem. And I'm going to pick on page 2-8, I'm going to do problem number 4. So let me write that on the board. Page 2-8, number 4. Now you always read the problem carefully, maybe 2 or 3 times, and pick out the important things. So it says in here, I'm going to read it all the way through first. The car accelerates from rest to a speed of 10 meters per second in 5 seconds. If the uniform acceleration is uniform, determine the acceleration and the distance traveled during the 5 seconds of motion. So I read it, and I'm going to read it a second time. A car accelerates from rest. What's rest going to mean? What does that mean? Acceleration from rest. What's its initial speed? It means the original speed is 0. 0 meters per second. Then it says, to a speed of 10 meters per second. 10 meters per second, what's that going to be? That's going to be the same speed at some later time. So it's going to be 10 meters per second. And I keep going back to the book, I have to keep reading it. 5 seconds. So what's the 5 seconds going to be? Well, that's going to be the time. All right. Then it says determine the acceleration. So we know these three things and we're looking for A. Now which equation has these three things and we're looking for acceleration? Well, looking up here I see that equation right there. That has this one, and that one, and we're looking for A, so that should work. So I'm going to go down here, I'm going to write this, A times T, and I pick out the key things, 10 meters per second, 0 meters per second, A times what, 5 seconds? Now what I think we should do, I've been doing this for years by the way, is let's leave out the meters per seconds and seconds. Let's just deal with it as an algebraic equation. I'm going to go over here, I'm going to write it this way. 10 is equal to 0 plus 5 times A times 5 times A, right there. And now I'm going to write it this way. And I'm going to divide both sides by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. And now we have to remember to use the term, the units. And the units in this case are going to be 2.0 meters per second squared. Like that. All right. Now again, going back to the problem, we have to figure out part B, the distance traveled. The distance traveled during the 5 seconds of motion. So which equation can we use for that? Well, now we know what the acceleration is, but it's no longer an unknown. We have this, and that. Which equation can we use to find out the distance? Ah! There. There. Or in this case, even this one right here. So which one do you think we should use? Well, I'll tell you what, let's use this one just for example. But all three should work. So v squared equals to v sub 0 squared plus 2 times A times x minus x sub 0. All right. Now the final speed was 10. This was 0. We know now that A is equal to what, 2? And x minus x of 0. So 10 squared is 100. And let's leave out the meters and seconds. Hello.